Digital transformation has increased the importance of the network. The ability to connect customers, employees, cloud applications, and devices enables modern organizations to succeed. With every innovation, the underlying apps and services rely on the network to communicate and connect. But how does a reliable networking architecture support a digital transformation strategy? A fast, reliable, and low-latency global network ensures exceptional user experience and high performance. It also makes it easier to communicate and manage data globally. With ever more distributed workforces and online businesses, having virtual network services that can easily scale without adding hardware ensures that organizations can adapt. So how does a network operate? Let's start with the foundation of the modern internet, fiber optic networks. Fiber optic cables contain one or more optical fibers, which are thin strands made of glass or plastic. These fibers are used to transmit data as pulses of light over long distances. Subsea fiber optic cables carry 99% of international network traffic, yet we barely notice they exist. The first subsea cable was deployed in 1858 for telegraph messages between Europe and North America. A message took over 17 hours to deliver at 2 minutes and 5 seconds per letter by Morse code. Today, a single cable can deliver a whopping 340 terabits per second. That's more than 25 million times faster than the average home internet connection. Every shared video, sent email, and downloaded app depends on data traffic that moves through international network infrastructure. But how is this content available to people within milliseconds? A rich ecosystem of companies and local providers build a global infrastructure that provides businesses and people around the world with the best possible internet experience. These include companies like Internet Service Providers, or ISPs. ISPs provide access to the internet to both personal and business customers, handling the traffic between the customer and the internet as a whole. Some examples of ISPs include Verizon, Vodafone, and SoftBank. The infrastructure that makes Google's global reach possible is our network of fiber optic cables that run on both land and sea. This network connects our data centers and points of presence like highways connect major cities. Google owns and operates data centers all over the world. In these Google data centers, products like Search, Gmail, YouTube, and Google Cloud are run for people and organizations around the world 24 hours a day, 7 days a week. Within this vast global network, how do all the different parts recognize and communicate with each other? There are protocols that make it work. Let's start with an IP address. The IP stands for Internet Protocol, and this address is a series of numbers that can identify a network or the location of a particular device on a network. A domain name is an easy-to-remember name that maps directly to an IP address or set of IP addresses on the Internet. It's the unique name that appears after the @ sign in email addresses and after www. in web addresses. For instance, the domain name example.com might translate to the IP address 192.168.200.8. Other examples of domain names are google.com and youtube.com. And then there's a domain name system, or a DNS. A DNS server stores a database of domain names mapped to IP addresses that can be queried and used by computers to communicate with each other. This system is like the phone book of the web. Every time you visit a website, your computer performs a DNS lookup. A phone book translates a name like Acme Pizza into the correct phone number to call. Similarly, the DNS translates a web address like www.google.com into the IP address of the computer hosting that site. In this case, it's the Google homepage.